We have gone through 3 chapters already. Chapter P was like the prerequisite to review for review Algebra 2 in preparation for this class. Chapter 1 was all about analysis, making sure you know how to look at every part. Chapter 2 is polynomials and rational functions. And then chapter 3, we're going to look at exponential and logistic functions. That's going to be the big idea for entire chapter 3. All right, let's look at this first one. So this is an exponential function, and exponential function have this kind of structure. So this first part, this b is the base of the exponential function, b for base. And the difference between exponential and polynomial function, can you guys tell the difference? So a typical polynomial function is something like this, right? What's the difference between exponential and polynomial?
Polynomial is like adding.
You could add exponential as well. But yes, there is adding, but the biggest difference is the x part, yes? Kind of. They are both not constant. Okay, so the key part is the x. What's the difference? Yes. So x is now the power of the base. Before, x is the base. Okay, that is a very big difference. That is the key difference between exponential, which means x is in the exponent, and polynomial, where x is not. Okay. All right, next a. A is the number you multiply. This is usually the initial value, usually, but not always. And it's also the stretch and compress, right? Kind of, because it's the number we multiply on the outside. So we can say this is initial value. I'm going to put sometimes because it's not always the initial value. All right, now the base. The base can only be positive. If it's negative, it's not an exponential function anymore. It goes up and down like this. It's very strange. Only when it's positive, we have like an e to the x graph. That kind of exponential graph. All right, so let's go ahead and have you try 1, 2, 3, 4. Whether it's an exponential function or power function, remember power function from last chapter is anything that looks like a polynomial, but only one term, so like a monomial. And what is the base? Remember the base is on the bottom. All right, go ahead, 1, 2, 3, 4. All right, let's start with McKenna. Number 1, exponential or power? Exponential. Ashley, what's the base? Caleb, number 2, exponential or power?
Power.
And I'm not sure if I would ask Mark what is the base, but for a power function, we don't really talk about a base. It doesn't actually make sense. They're all x's, so I would just skip it. All right, so Mark, you can answer this next one. Number 3, exponential or power?
Exponential.
Trey, what is the base?
1.5.
Andy, what is number 4?
Exponential.
No. Josh, you want to try? No, it's not. Do you guys see an x? No. So this is neither. What is this actually? Think. Yes. Yes, it's just a line. There's nothing in here that's not a number. Pi is just a number. So this is just a straight line. All right, let us just make sure we can do this. Very quick review. F of x is 2 to the x. So f of 4 means what? 16, yes, 2 to the 4. So 16. I think you guys should be okay. All right, go ahead and do the rest. Let me know when you're done. All right, first one, this one, f of 0 is 1. This one, 2 to the negative 3. That is 1 over 2 to the third. That is 1/8. 2 to the 1/2 is square root 2. 2 to the negative 3 over 2 means 1 over 2 to the 3 over 2. That is 1 over, 2 is on the outside, 3 is on the inside. So this is 1 over square root 8. Simplifies to 1 over 2 root 2, which simplifies to square root 2 over 4. So you need to be able to do all that really quickly. All right. Next. Let's go ahead and look at exponential graphs and how we can write an equation of that graph. So what we want to do is remember our function here. A times b to the x. A times b to the x. Do not multiply a and b together. B is the base. A is the number, the constant that's multiplied to the base. They cannot multiply together. Okay, this is key. A lot of people multiply them together. All right, so we have this exponential graph. This is the exponential graph. You have to notice this as the exponential graph. This shape is the exponential graph. Okay, first we need to write a equation. So we need to write out the basic form. In this basic form, a times b to the x, what are the only two things we need to solve for to have an equation? Blake? Yes, a and b. We need to find a and b. So if we have two unknowns, a and b, how many equations do we need to solve them? 2. Okay. Okay, we need two equations. Where are those two equations going to come from? Yes. All right, talk to your partner. Where are those two equations going to come from? I need a and b. I need two equations in order to create two variables. Where are those two equations going to come from? And we're going to use this graph. Hint. So talk to your partner. Where are we going to get those two equations from? All right, Andy and Trey, what do you guys think?
You could use 2 points on the graph to make vertex form.
Okay, yeah, make not the vertex form, but yes, use 2 points on the graph. Very good. Aaron and Jennifer, what do you guys say? Same?
We were thinking of the 2 points, the one on the top and the one right on the y-axis.
Good. So yes, we're definitely going to pick 2 points in order to solve a and b, because that's going to create two equations. Now, which 2 points? Aaron and Jennifer says these 2 points, those are good points. Why are they good points compared to these other 2 points?
Whole numbers.
They are whole numbers, yes. These numbers are not whole numbers. It's a little bit harder to figure out what they are. You may be able to figure out what 1.333 is, but 0.444 might be a little bit harder. Okay, so you want to use whole numbers. That's going to make your calculation easier. Now we're going to plug those two numbers into the equation. That's going to create two equations so that we can solve. All right, 0, 4. 0, 4. 0, 4. Another way to think about 0, 4 is if you put in 0, you get 4. So f of 0 gets you 4. So that means 4 is y. A we don't know. B we don't know. But x is equal to 0. Can I simplify this? Okay. Sally, tell me how we can simplify this. A is 4. Y is A 4.
B is equals to 1.
B to the 0 is 1. B to the 0 is 1. So A is equal to 4. Yes. Now we're going to use the second point, which is 112. Okay, so 12 is Y. A, we already know, is 4. B, we don't know. Please don't multiply A and B together. X is equal to 1. What does B equal to? 3. The last thing, put it all back together in one equation. Y equals what? Yes, 4 times 3 to the power of x. Is this the same? No. So do not multiply a and b together. This is not the same. It is not the correct function. All right, let's have you practice one. This time you don't get a graph, but you get a table. Table with x and h of x. It's still the same idea. You're going to pick 2 points. Remember, you want to pick 2 easy points. And the reason you can do this is, read the question. It's an exponential equation. If it doesn't say it's an exponential equation, if it says it's polynomial, you cannot use a times b to the x. So you have to read very carefully. It says it's an exponential, therefore you're using exponential function. Okay. So go ahead and solve it and let me know when you're done. Okay, h of x is equal to 8 times 1/4 to the x. Exponential growth or decay. So if you look at this equation here, as time goes on, so as t gets bigger or as x gets bigger, is this function growing or decaying? Growing. It's getting bigger, right? So this is called growth. If it's decay, that means it's going to get smaller over time. How can you tell if something is going to be growing or decaying based on the base? Well, if the base is greater than 1, it's exponential growth. If it's between 0 and 1, it's exponential decay. Can the base be negative? No. The base can never be negative. If it is negative, it's not an exponential function. All right, so let's have you decide 1 and 2, growth or decay. All right, Evan, number 1. And then Sherry, number 2. All right, transformation. So the transformation idea is the same as before, where we have, this is the parent function, f of x equals a times. Now the base b has nothing to do with the transformation. That is just the parent function. B to the, and we have x minus h. But this time it's going to be over c because we have the horizontal stretch and compress. And then we have a plus k that comes outside of the function. So it's the same thing as before, a, h, k, but this year we have a new letter c that has to do with horizontal stretch and compress. And remember, h is inside the function, k is outside. The parent function this time is b to the x, whatever b is. It could be e, could be 2, could be whatever that number is. It is the entire parent function. So let's look at number 1. What is the parent function? Everybody. E to the x. Good. So then the only transformation is this 2. The question is, what does the 2 do? Stretch. If it's a vertical stretch, that number would be outside of the function. This one's inside the function. It is a horizontal something. It is a horizontal compress. So you're going to have to remember from, I think, 2 chapters ago when we did transformation a little more often. We said that that number has to be a number in the denominator. So in order for that to happen, we change it to the reciprocal and then put it in the denominator. So now that c value is 1/2. 1/2 is less than 1. Or between 0 and 1, so this is going to be compress. So horizontal compress. Horizontal compress 1/2. All right, number 2. This one is a little more tricky. First of all, what's the parent function? 3 through the x. Yes, 3 to the x. So now we have three transformations. We have the 2, we have that negative sign, and we have that plus 4. So let's have you guys work with your partner. What is the transformation That negative inside is very tricky, so please double check. All right, so let me kind of show you this, and then I'm gonna call on you to answer this for me. All right, Junior, first transformation. Left 4, that is not correct. Blake?
Go right 4.
Yes. Okay, Allison. Reflect. Yes, y-axis. Because the thing is inside, not outside. All right, Eunice, you have the last one. Huh? Vertical stretch by 2? Yes. All right, number 3. Let's have you guys try this one. It should be pretty easy compared to number 2. Okay, Alana, number 3. Give me one transformation. Reflect x-axis. Okay, Amelia? Huh? Yeah, so let's say up 3. And then Sally, can you tell me what the parent function is?
0.4.
Yes. All right, so that's exponential function, and we're going to come back to it a little more later. But the other big thing of this chapter is this logistic function, which you have not seen before except for this graph, right? So at the very beginning of the year, we talked about the logistic function, but we didn't really do anything with it. Logistic function is very interesting. It is just like the exponential graph, except it kind of curves down or flattens out. And in fact, it has 2 horizontal asymptote. So let's kind of compare the 2 graphs. The exponential graph looks like this. The logistic graph looks like this. And the difference is one of them has 1 horizontal asymptote. So exponential graph never goes below whatever that number is. There is a number that doesn't go below. Horizontal asymptote actually has, logistic graph actually has 2. One on the bottom and one on the top. So you have to know that there are 2, because if you sometimes graph it with your graphing calculator, it might not actually show you 2. And if you don't know what you're looking for, you might miss it. So please be careful. All right, so this is kind of the general function. You have a b to the x, that is the part of the exponential graph, but there is a 1 in front, and then there's a c on the top. So it's kind of crazy, and if you were to solve it, it would be kind of crazy. All right, so we're going to take this exponential graph, logistic graph. We're going to find the y-intercept and the horizontal asymptote by graphing. And actually, I'm going to show you how to do it algebraically, because sometimes algebra is a little bit faster than doing it by graph. All right, first of all, y-intercept. Y-intercept is when what happens?
X is 0.
Yes, very good. X is 0. So that means when x is 0. We're going to solve it by plugging in 0 for x. All right, go ahead and figure out what this is. Please make sure you follow PAMDAS, your order of operation. Hey, Aaron, did you solve it? Okay, what's your answer?
2.
Good. All right, now we're going to graph it and figure out where the horizontal asymptotes are. All right, so when you graph, please be careful. You're going to have to put this whole thing in parentheses. In fact, you might want to put this in parentheses as well. Okay, so try it. 8 divided by parentheses 1 plus 3 parentheses 0.7 to the x. You should see the graph like a logistic graph. If you don't, that means you're too zoomed in. You might want to zoom out so you can see the 2 horizontal asymptotes. Okay, so the graph looks like this, right? What are those 2 asymptotes? One's on the bottom. What is this one? Y equals what? Guess? Yes, 0. And then there's another one on the top. You You have to guess. I'll show you how to find the actual numbers later algebraically, but right now you just have to guess. What is that asymptote? Huh? 8. Yes.